This Oakland Data Transformer tutorial covers Java support. This is part 1 of 2. This part will cover importing the Java classes and the default subclass mapping support. The Java classes that we're going to be using are shipped with the examples project that comes with the ODT. So the first thing we're going to do is create a new Java project so that we can manipulate and execute those classes. And then we're going to copy the Java classes from their location in the examples project and we see we get some compile errors, and the reason for that is because some of these classes depend on the ODT runtime. So we'll need to configure the build path to add the ODT jar file. So to do that, we'll add an external jar file into the build path libraries. And the ODT jar file can be found in the ODT runtime kit, runtime API kit, which I've already expanded here. So we'll just use this ODT API jar file, and that will make the compile errors go away. So now what we want to do is create a separate ODT project as well, which we'll use to keep the maps and structure definitions that we're going to use in this tutorial. So it'll be a data transformer project. Now we're going to import the Java classes into the ODT to create the structures. So we'll switch over to the data transformation perspective, and we'll just use the import operation. Select data transfer, select Java class, and we'll put this in a folder called Java. And we're going to import from resources in the workspace. So we're going to import from the class files that are contained in the Java project that we just created. And the only ones we want to import are the domain objects for these accounting objects. We don't want to import other support classes, so we'll select this directory to import. We want to use the simple class names. And when you select a directory to import, it automatically sets your class path to be that directory that we're importing. But in this case, that's not correct, because we actually want our class path to be this bin directory here. So we'll remove this, and we'll add a resource to be the class path, which will be the bin directory. And then we continue with the import. And the import's done. And so now we have our structures created here. So here's our Java structure that corresponds to the invoices class, and we can see all the elements here which correspond to the bean properties. So then the next thing that we're going to do is create a Java sample object that we can use with this structure here. So right now, if we're in the structure editor and we do a show document, it's going to ask us to pick a sample document. Well, we don't have a sample document because we haven't created one. Java sample documents are stored in Xstream format, just the standard Xstream serialization format, and they can be created in a number of ways. The easiest way is to include in your program a little bit of code to do that. And so we provided a sample Java program here, which creates the sample documents by calling a method to create an instance of the test class. So if we switch over to the Java perspective, if we go to this create test invoices method, we see this is a static method which will create an invoice, create the entire invoice object graph, all the invoices and all the objects associated with that. So we can run this Java program here, and it will create this Java object, and then by calling this add sample data method on the runtime engine, it will automatically serialize that object and include it as a sample document for the specified structure. We need to change a couple things in here, so we're not putting it in the copy of examples project, we're putting it in a project called Transform Java. and the rest it's fine. So, and then the other thing we need to do when we run this is we need to set up the ODT dev workspace to point to the workspace that we're using so that it knows where to put the file. So we'll select the run configurations here, and we're going to run it as a Java application. We'll create a new run configuration. This is just standard Eclipse, and we'll add the system property for the ODT dev workspace, and we'll set that to be the workspace location. We'll just use an Eclipse variable to do that. Okay, and now we'll run it. We refreshed and we see that it in fact did run, so it didn't show anything in the console view. Normally if it runs it works fine. It doesn't show anything. So we'll go back over to the data transformer perspective and we'll look at the invoices and we'll do a show document, and we'll see now that it's actually showing this Java document here. So this is the way that we can use, just like anything else with the ODT, it supports sample documents of any sort of XML, EDI, flat, whatever. You can use the same thing to carry around essentially complete Java object graphs so that you can test your Java maps using that. So since we've associated a sample document with this invoices structure, it's now dirty, so we'll save it. So the next thing we're going to do is create a Java map, a Java to XML map. To create the map, we'll use the new map from the Project Explorer. Selecting a standard map, Java to XML. We're going to use the invoices structure that we had previously imported. And for output, we'll output to one of our sample structures, this Acme PO file XML structure. So now we have our map. Nothing's mapped at this point. So let's start doing a few mappings. We can map the purchase order number to the number over here. And we can execute this one element in the map. And we see that it's produced a number. We can then verify that that's correct by looking at the input. And we see it's the same number. Next thing we can do is map a date. So we'll map the due date here. Let's see if we have a value there. We do have a value, June 1st, 2009. So we'll map it to the date in the purchase order. And we'll run that. And we get the same value in a different format, which is fine. But it looks like we're getting a warning too. So the warning says that we're trying to convert a date time to a date, so we're losing some information. So let's fix that. To do that, we'll use the extract from datetime function. So we'll delete our value expression here, and we'll pick out the extract from datetime and drag it in here, and use the due date as the argument. What is extracted is a property of the function. So if we look at the function properties, we see extract what date. That's the default. You can extract a number of things from it, but we'll just use the default. So now if we run it, we won't get a warning anymore. Next thing we're going to do is map some conditions. So we have as input, we have a set of these invoice condition objects, and we want to pick one that has the description of urgent, and we want to use that to populate the urgency value in the output. So if we find an entry in here with urgent, then we want to use the right now value for urgency. Otherwise, we'll use the anytime is fine value. So to do that, we know we want to if then else, because the if condition, if it were true, we would want the right now value. If the else condition, we want the anytime is fine value. So the condition we want is we want to find out if there's a member of this set that has the particular value that we're looking for. So what we want to do is we want to look for something that has some value, this non-empty, non-blank, and we want to get the first present value using an aggregate function, because we want to basically loop through this set. So we use this aggregate aggcat first present value. It'll pick the first present value that it finds, and in this case we'll want it to match a filter. So what value are we looking for? Well, we want the description value here. Actually, it doesn't matter, since the only point is looking. We can pick any value here that would not be blank if it found something. So we'll pick the description, and when we use an aggregate function, the first argument below the argument of each argument of the aggregate function is a loop expression. So that says what kind of loop are we using to populate to determine the input of this function for this argument, for this invoices argument. So in this case, this loop is specifying a nested loop. It's specifying that we're going to simple loop through invoices and the condition set, which is not what we want, because we don't want to look through all of the condition sets for all the invoices. We only want to look through the invoice that is related to the enclosing loop here, which is this loop on invoices. So we'll want to modify this loop expression a little bit. We can get rid of the nesting here, because we just want a simple loop, and instead of looping through invoices, we want to loop through the condition set. So it's pretty intuitive once you understand it, that you just want to loop through the condition set. And now what we want to do is add a filter, and we're going to check for equality. So we'll use the equal function on the filter, and we're going to want a constant, which is urgent, and we'll want to compare that with the description value. So, and then if that's all true, so this is all the condition of the if statement here. We can make this a little bigger so you can see what's going on. So if then else, the condition, if there's some value in finding an aggregate concatenation of the first present value, meeting this loop expression over the conditions with this filter. So if it finds something that meets this filter, then this has value, will return true. If it doesn't, then there won't be any value. Either there'll be elements in there that don't meet it, or it will be empty. So if it does have the value that we want right now, so we can just drag a code value right to then, and it'll just make a constant function. Otherwise, then we want anytime is fine. So this is an example of the use of an aggregate function here, an example of going through a set. This can be used for any kind of loop, really, and all of the Java collections manifest as loops. So now let's run the element and see if we get what we expect. So we're getting RN, which is right now, and we would expect that given that the description is urgent. So let's then, just to be sure here, let's just change it. So let's change it to look for something that's different than urgent. So I'll just put some characters there. So here it shouldn't meet this filter. It shouldn't find anything, so it should take the else of the condition. So now we'll run it, and we'll see we get the else of the condition anytime is fine. So we'll just fix it back. Should be able to just undo it, and it'll fix it back, and we'll just run it just to test it. And there we go. So now that showed mapping of a set. Like I say, it can apply to any sort of collection, this use of an aggregate function. And then we'll also show how a map is represented. So here we have a map, and maps have a key and then a value. So this conditions map here, we can actually go look at the invoices object. We'll go over to Java land here, and look at the source of the object. Look at the source of the class. Oh, we want invoice. And we see it's a map of a string to an invoice condition object. So the invoice condition class is the class that we saw before. So let's go back over and look at our map. So the key here will be some string, and then the value will be this this invoice condition object. So let's see what the values that are actually in the sample. Looks like we have two values here, a key of 2 with this condition type, and a description of 2, and then a key of 1. So here what we want to do is let's populate the notes here with the contents of this map. So basically we're just mapping one loop to another, and that's a pretty straightforward operation. Let's put the key and then a hyphen and then the description. So here we're going to concatenate a couple values, and we're going to use a constant to do that. So we'll just map a concatenation function here, and we'll map the key, and we'll then map a constant, and we'll drag it in between here. We'll put a hyphen in the constant, and then we'll map the description. Went in the wrong place. We can just drag it to the right place here. Okay, so we have the key in the description. So now notice when I drug that there, the loop got populated. So it automatically populated the loop for the conditions. It automatically populated the loop expression for the conditions map, which is what we want. So now let's run it, and we see that we're getting 2 notes and that they correspond to the values that are in the map. Again, this is a list here. So this invoice has line items, and here we have a level called delivery, and under delivery we have items. So we'll change our looping for delivery. Since we don't have a corresponding delivery loop here, we'll say that we always only have one delivery. So to do that, we'll just, for the loop expression, we'll make that a fixed loop. So we'll say fixed loop, and by default it assumes one time. So the delivery is going to loop once, and then we'll just map some of the things in the line item. So we'll map the part number, and we'll map the quantity, and now if we execute this, we'll see we get these 3 items here, and if we go look at the line items that are in our invoice, we see that there are 3 of them with these quantities. So now we'll run the whole map, and we see we've got the number, the urgency, the date, we've got these notes based on the map, and we've got all the items. One more bit of mapping we're going to show is how to map something which uses the Java subclass support. So in the main contact property, what we have is the type for that object. If we look at our source, the invoice, if we look at main contact, the type for that is a contact. So the contact class has several subclasses, including nested subclasses. So what happens when we import the Java classes is that it creates it creates the values of an element here, the fields of the element, and it puts the superclass, the fields that the properties that appear in the superclass first, and then it adds any additional properties for each level of subclass. So this allows you to conveniently reference any of the properties depending on which object shows up. So we're going to show the mapping here of this contact object. Let's look at it. And it's the subclass called American Contact. So what we'll do is we'll map the properties in that. So we'll map the person here to the vendor name, and it looks like some of these will line up the street and the city. They'll match up by name, because if you just drag and drop a parent element, it will map everything. It'll map everything underneath it by name, ignoring case, which is what we want. And then, since it's an American contact, it has a state and zip code, so we'll map those as well. So now if we run the map, we'll see that the vendor name appeared and all of the address appeared. So it dealt with handling the fact that an American contact appeared in this case. In the mapping of the other direction, XML to Java, which we'll show in a bit, will show you how to create the appropriate type of object going out. Now we're going to go the other direction, and we're going to create a map from XML to Java. So we'll creatively call this XML to Java. And for the input, we'll take this same XML structure we produced in the output. For the output, we'll take the Java invoices structure, and we'll just map the invoice number to the PO number, just to do something there. And then the other thing we'll map, we're not going to map everything else because basically the way of handling all the collections and everything is pretty much the same. So what we will do, however, is we'll map the main contact as we did before, which will show you how to output the appropriate subclass. So the main contact, we want to use the person as the vendor name, and then we want to have the address information, pick up the street name and so forth, and we want to also use the American contact to get the state and the zip. So there's our mapping. So let's run this, and what we get when we run is we get an error. So it's telling us that the class attribute of the Java element is not populated with the name of the class. So and it's invoices main contact. So it's this element here, and the way that the subclass support works by default is in these attributes which are provided, and in general, you don't need to know about these attributes for the Java case. So these attributes talk about the class and the collection class and various other things that are necessary to provide the Java support that you don't need to know about. But one thing you do need to know about, which is documented, is that in the case of an element that refers to a superclass, what it does is it actually generates a choice expression in the class value expression, which gives you a branch for each possible subclass that you can emit. So then you could put in the conditions under which you want to emit whatever subclass you want. So the result of this choice expression needs to be the fully qualified class name. So in this case, what we want we always want it to be American contact. So we could just use the constant value American contact, or another thing we can do is simply set the condition for that particular value to be true. So we'll add a constant under the condition here, and we'll set that to be true. So now if we run the map will work fine, and we'll see that the main contact then is properly populated with the street and city and zip code and with the type of American contact. So this is how you use, this is one way of populating the type of object that you want to be emitted when you're writing out Java. The next part of this tutorial will show you a different way, and there's different reasons to use each way. The main reason one of the main reasons you'd want to use this way is simplicity, and another is if you're using map inheritance, where you actually have to have different maps for different levels of your Java hierarchy. This is really the only way that is going to allow that to work properly.